Hi guys. Um, I am, and all teachers across the world are very confused about the AP exam. So if you are also confused, that is perfectly justifiable. Um, I have tried really hard to make it clear on Blend what is happening. I have provided links. It is going to take quite a if you want to figure it out on your own, I have put everything up there for you, as many links as possible. But if you want to schedule a conference with me, please feel free, because I will answer any questions I can. It's really important that you know the formula's cold. So I have opened that formula quiz for you. It should work. If it does not work, you need to let me know. The best piece of this, and I think that some of you are going to be really pleased about this. These problems are supposed to be designed in such a way that you can actually practice your little took-us off and do well. So you want to look at any and all free response questions. In response, the College Board has made all of the free response questions on AP Classroom available. They have also made 5 Steps to a 5 available to everyone, and I will post that link as soon as I am able. 5 Steps to a 5 is considered the best review resource out there that is not produced by College Board. We also are familiar, as a class, we are familiar with Delta Math. I will post something from Delta Math or a link for Delta Math up there and assign you some things out of there so that you can practice, because what you want to be doing between now and May 12th, and the date has been moved to May 12th, what you want to do between now and then is practice, practice, practice. The biggest issue that I currently have with this whole thing is that you may only take the BC exam or the AB exam. You cannot take both. So that made me very sad, and many other teachers across the world sad. So you have 3 choices at this point, and I would encourage you to begin with the first choice, which is to gear up for the BC exam, do the best that you can. Come late April, you're going to want to decide whether or not you feel like you're ready for the BC exam. And if you feel like you are not, you're going to want to switch gears and switch to the AB exam. If you really feel like you're not ready at all and this whole situation just completely freaks you out, and you don't want to make this decision until late April, only because you have plenty of time. Like, don't worry. And you can do this. You can make any of these changes right up until the 24 hours beforehand. You can cancel your exam and they will not charge you. I'm not sure if that's a 100% refund or not, but I wanted to let you know that you have those 3 choices open to you. Again, I'm discouraged that you can't take both the AB and the BC exam, but what can we do? We don't rule the world. So, okie dokie. Moving on. Okay, I remember talking about this whenever we did the integral test. Oh, and by the way, you need to make sure you're actually taking notes in this big paper notebook. I don't know what to call it, workbook that I had printed off for you. It is not enough to just watch these videos. You need to take notes and try stuff out. So, I can imagine based on our experience. I can imagine based on our experience in the Zoom meeting that certain people, named Aiden, probably don't take notes during this. You need to push pause and take notes every time we go through this, because you're just not going to remember. Nobody has that kind of memory. Okay, so a series of this form where you've got 1 over n to the p is called a p series, where p is a positive constant. For p equals 1, the series is called this series, the sum from 1 to infinity of 1 over n. That is called the Harmonic Series. The integral test can be used to prove the P series. We're not going to go through it, but let's look at the P series that were in yesterday's notes or Wednesday's notes, and see which ones converged and which ones diverged. If you look carefully here, every single series where your power is greater than 1 will converge. And every single series where your power is less than or equal to 1 diverges. Make sure you write that all down and process it all and write notes all over this. We talked about it last time, and we talked about it during our Zoom meeting where we did that exploration thing. Okay, trying to jog your memory, not trying to make you feel like you can't remember anything. Trying to hope that it jogs your memory somehow. So when you go into the AP exam, you're going to have to know this cold. Every year they've had to. A series question is almost invariably on the AP exam. A P series converges if P is greater than 1, but it diverges if 0 is less than P is less than 1, and it also diverges if P equals 1. That is referred to as a harmonic series, and it is important that you remember that actual title, the harmonic series, because oftentimes they actually refer to it and expect you to recall that title. So I feel like that's really awkward. Let me try that again. There we go. Oh no, that didn't work. Oh goodness. Goodness gracious. Now I'm just playing. I'm sorry. I can't help it. It's really hard to be stuck by yourself all the time. There. Okay. Harmonic series. There. Oh, that's pretty. It's purple. We're going to go with that. Okay. Okay, the sum as n equals 1 to infinity of 1 over the cube root of n is the same as saying the sum of from n equals 1 to infinity of 1 over n to the 1/3. So p is less than 1. Well, it's actually also greater than 0. Therefore, the series here diverges. On the next one, however, if you look carefully, you can see that your p-value is larger than 1. If your p-value is larger than 1, then your series converges. Okay, finally, if you look at the bottom, there is a homework assignment. This homework assignment might be slightly different than the homework assignment that is on Blend. Follow the homework assignment that is on Blend to prepare for the exam. David Shilliday and I worked really hard at kind of shrinking the homeworks, so always pay attention to what's on Blend rather than what's on this booklet. Got it? Okay. Okay, on the next one, if you have some sequence where both terms in the sequence are greater than, any term in the sequence is greater than or equal to 0, and you know that the series of B sub n converges, and you know that each term in that sequence is smaller, each term in another sequence is smaller than the terms in the known converging series, then the other series also converges. I'm going to translate what I just said because I feel like I really jumbled my words and I probably confused some of you. Give me 2 seconds to do that for you. Okay, so the verbiage is pretty tricky here, so I wanted to make sure I wrote down as much as I could to clarify. So when I'm talking about the known sequence, we know that the series converges. So that's what I mean by known. And unknown, all we know is that each term in the sequence is smaller than each term in the unknown sequence is smaller than each term in the known sequence. Okay, that's really confusing. The verbiage. Likewise, if we know that the series with smaller terms diverges, then the series with larger terms will also diverge. Okay, here we can see that 1 over n cubed plus 1 is super similar to 1 over n cubed. It's just a little smaller, so we can say that it converges by the p-series test, because if the larger one converges, then it only stands to reason that the smaller one would. I have put in some math notation in here that I haven't used very often. I'm going to point it out real quick. This right here is for all n an element of the reals. If you can get your brain wrapped around how to create that sort of notation, it will save you time on the AP exam. Once we have said that one of these series is smaller than the other and each term is smaller than the other, then we can say that the unknown series or the series in question converges by the direct comparison test. So when you're doing these problems, it's important that you communicate with whoever's going to be grading this. So you can see right away that this particular series is similar to the sum from 1 to infinity of 1 over 3 to the n, which converges by the geometric series test. It is important that you understand that all of these words are necessary in your answer. So you need to justify why it converges at each point. Once we have stated all of that, we can say that each term is of the unknown series is less than each term of the known series. Therefore, we can say that it converges by the direct comparison test. Again, it is important to note that all I have done here is write the answer. I have not at any point written down anything to explain anything to you except this tiny piece in here. That right there, I don't know if you can see that. That's a little more visible. That piece right there, you can say either what precedes that or what's in parentheses over there. But this is your entire answer. This is like proof from geometry. If people have not taken pre-AP geometry, I do not recommend they ever try to take BC because they've never seen proof before. They may have seen a smattering of it, but not enough to be able to get through this piece of BC. In this case, our p-series is similar to the p-series that we know, which is 1 over the square root of n, and it's a sum from n equals 4 to infinity. And why do we start at 4, not 1? Because if we were to put 1 in the original, right here, if we were to put 1 in there, we would have 0 in our denominator. So we had to start at 4, and that doesn't change the series very much. It's still approaching the same thing. Our known series diverges by the p-series test for all n greater than or equal to 4. Therefore, the new series diverges by the direct comparison test. I'd also like to point out that I used the alternate comparison. I looked at the individual terms and just stated that comparison or inequality. Let's see, what else was I going to say? I thought of a random reassurance for you. Don't worry about your handwriting. Nobody in this class, not a single one of you, has handwriting that is worse than anything I've ever seen at the reading. So don't worry about that at all. Okay, on this last page, if you look at this carefully, if you have two series where both sets of terms are positive, if your limit of one of those, if your limit, I can't talk. Okay. If the limit as n approaches infinity of one of the terms divided by the other term actually exists. So we're talking about the far end of those terms, right? Because n is approaching infinity. That limit where that limit exists is both finite and positive. Then the two series either both converge or both diverge. So in order to actually find what they converge to is a different question. This just determines whether they both converge or both diverge. As n approaches infinity, this series is going to start to look more and more like 1 over n because the power in the denominator is 1 greater than the power in the numerator. So let's just see what happens. We have this known series, 1 over n. Let's try dividing our unknown series by our known series and see how that simplifies, whether or not the limit of that division actually exists or not. So as you can see here, our limit actually equals 1/4, and if you can't see what happened between this step and this step, well, I'm going to try to take you through it quickly. That 1 over n right there, I took it and I multiplied both, I'm sorry, not both. I took it, there's this little rhyme that I learned when I taught at Adobe. Multiplying fractions, that's no problem. Top times top, multiplying, oh crap, I gave you the wrong one. Dividing fractions, y, ask y, just flip the last and multiply. So we take this bottom one, we flip it, and we multiply this top part, oh, you cannot see that, by n over 1. Let me see if I can switch colors real quick. There. We're multiplying both this top by n over 1 because we've flipped the last and multiplied. I never thought I'd need that for the rest of my career. Anyway, okay, so we found a limit right there. And once we have that limit we can see is finite and positive. Therefore, our unknown series diverges just as the harmonic series does. On this next one, we see that it's super similar to the series 1 over n cubed, which converges by the P-series test. So we're going to go ahead and divide those out and try to figure out whether they both converge or diverge. Well, they will converge, but we need to show the work and prove it. So here we're taking our mystery series and comparing it to a P-series that converges by the P-series test. We divide the unknown series by the known series, or the mystery series by the known P-series, and we take the limit as n approaches infinity, and we discover, lo and behold, that that limit actually equals 1. Once we've determined that, it is, in fact, a finite and positive limit. Therefore, the entire series does converge. I'm sorry, the unknown series, the mystery series, the series that we're examining, actually converges. Okay, so you see here that the series in question actually converges. We don't know what it converges to, but I also just noticed that I made a weensy little mistake. Right here, oops, wrong color. Right here, oops, wrong opacity. Let me bring that up to maybe 50. I wish you could see what I was doing. This is such a fascinating tool. Anyway, right here, that should actually be n equals 2. So I would encourage you to fix that in your notes. And once you've done that, we are done for the day. I'm trying to hit like